going into the laws of motion, we are going to go into the first law first. So the first law of motion is also known as the inertial law. So before we go deep into what it means, I have a question. What happens when a driver suddenly hits the brakes? So if you're ever driving with your mom, what happens when, oh my gosh, I almost ran over, I don't know, a cat or whatever it is, something comes in front of the car and then they suddenly brake. What happens to you?
You're pushed forward, or like your body moves forward.
And why do you think you move forward?
Because you're moving at the same rate as the car, so when the car stops, you're also going at the same rate as the car is.
Yes, and this is known as inertia. So I remember when I was in 8th grade, I memorized the definition of inertia. So I know inertia as the tendency of an object to resist a change in motion. However, a lot of people think of it like this. An object in motion will stay in motion unless the unbalanced force acts on it, or an object at rest will stay at rest unless an unbalanced force acts on it. So an object in motion will stay in motion and an object at rest will stay at rest. So this is basically the first law of inertia. The key points here is that the forces are balanced and and the net force is 0 newtons and there's a 0 acceleration. Now, does anybody know why the forces are balanced and why the net force is 0 on inertial law? If you think about an object in motion is staying on motion, that means it's like a constant speed, or an object in rest. Why are the forces balanced? What does it mean for the forces to be balanced? There's a fancy word that starts with an E. Anyone know?
Equilibrium? I don't know.
Yes, equilibrium. So if an object is in equilibrium, they're not accelerating, the forces are balanced. That means that the net force, if you take the sum of the forces, you're going to get 0 newtons. That just means it's in equilibrium. Zero net force does not mean at rest. It just means there's 0 acceleration. So it's either you are at rest or you're moving, but with a constant speed. So these are just the key points to remember about the first law. The inertial law, if an object is in motion, it's not going to move, nothing's going to happen unless there's another external force acting on it. But until then, its forces are balanced. And same thing with an object at rest. It is going to be at rest until something disrupts that. So there's an example here. Rest in peace, this guy, whoever it is. But he crashed his motorcycle and he went flying forward. This is the same idea with the question that I asked earlier with when you're in the car, suddenly someone hits the brakes, you want to keep flying forward. This is why we have seatbelts. Because if you don't have a seatbelt, you can get ejected from the car. It's not going to be pretty. So this is why we have seatbelts. Also why we have, airbags, because if you're going to go forward, you don't want to hit your head on the dashboard. So that's a hard surface. If you're going at a fast speed, that's not going to be pretty. So that's also why we have airbags. So this is basically the first law of inertia. Any questions with first law? If not, I also, a long time ago, I saw this meme. And it asked, oh, why is it so easy to stay awake until 6 a.m., but so hard to wake up at 6 a.m.? And they say, well, hey, things in motion tend to stay in motion, while things at rest tend to stay at rest. Although this is not accurate, it's a good way to think about it. Of course, it's not a physics thing of why you can't go to sleep at night and why it's so hard to stay in the morning, but it's a good explanation on the first law. An object in motion will stay in motion. An object in rest will stay at rest. I like to use this as an excuse as to why I cannot wake up early in the morning. It's like, hey, inertia, the law of inertia, first law. But I thought that was hilarious when I saw it. Now, whenever I think of Newton's first law of motion or of inertia, I think of this meme. So I'm never going to forget it, which either could be a curse or I'm actually kind of happy because I don't have to work hard to remember this law. All right, so the second law, it's basically the net force is equal to mass times acceleration. F is equal to ma. So This just says that the net force on an object is equal to the product between the mass, an object's mass, and its acceleration. So I don't know if anyone celebrates May 4th. And in May 4th, they say either may the 4th be with you, may the force be with you. It's a little quote from Star Wars, may the force be with you. And instead of saying may the force, you say may the mass times acceleration because that equals force. It's something lame, but I've actually heard a lot of physics people say that in May 4th here at university. So just a good way to remember it. But the key points is that the forces are not balanced. And the reason we know they're not balanced is because if we have a net force that is equal to force and mass and acceleration, if there's a net force, there is an acceleration. So that means there has to be some unbalanced. They're not completely balanced. Otherwise, there would be no acceleration. An object would be either at rest or constant velocity. So there would be no net force. But the key points here is that the forces are not balanced. There is a net force and there is an acceleration. So these are just things to remember about the second law. And if you have questions, you can just stop me. The third law, this is for every action, there's an equal and opposite reaction. And the way that you, if you want to think about this mathematically, is that the force of object A on object B is equal to the negative force of object B on object A. So for every action, there's an equal and opposite reaction. So this is actually what is known as action-reaction pairs. And there's a lot of questions on that, and we'll talk about these later. If we have time, we'll go over some examples. And you see what I'm talking about with action-reaction. So that's the definition of the third law. Basically, for every action, there's an equal and opposite reaction. And the key points to remember is that here the magnitudes are equal, but the directions are opposite. So let's say I push on the wall with 50 newtons. The wall is going to push on me back with 50 newtons, but in the opposite direction. So I'll just do negative 50 newtons. So this is actually how rockets work, and this is just the basic idea behind thrust. So you have an exhaust flow being pushed forward, and then the engine is pushed this way. And this is how a rocket works, just the very basics of like rocket science. You have a rocket, and it has an engine. The engine had some very explosive reaction, and so that's going downward, and that pushes the rocket upward.